Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, I have designed modeling pin diode for on switching in reconfigurable antenna. Modeling of pin diode for on switching in reconfigurable antenna. So now here in this video, I am going to explain modeling of pin diode for off switching in reconfigurable antenna. So first, uh, change the project name, right click on the project. Okay, so this is the modeling of pin diode for on switching, and this is a S parameter curve. So first you export this one, and after comparing on switching and after switching. So now change the project name, right click on the project, save as button, and this is pin diode off state. Click the save button. So first disable this radiation box, and this is the on switch. So this combination of four strips representing RF switch is in on state. So now I am going to design RF switch is in off state. And first of all, and what is the pin diode, and what is on switch, and what is off switch? So this is the on switch combination. Inductor is connected. Inductor. This resistor is connected in the series form of this inductor. So this is the on state, and this is off state. And resistor and capacitors are connected in parallel form of this inductor, that is off state. So the pin diode is a simple technique of electrically modifying of functional properties of the antenna by the switching state of the diode. The pin diode conducts current in one direction only, and therefore determines the on state and off state respectively. When the diode is forward biased, that is on state. When the diode is forward biased, that is on state. And series combination, the equivalent circuit is a combination of parasitic inductance and the series resistance as shown in this figure. So this is the diode is in on state, and the diode is in off state. When a reverse bias voltage is applied, the diode is known to operate is in off state. So with the equivalent circuit combination, equivalent circuit containing a large resistance. Consider the large resistance. In on state, the resistance is a small value. For off state, the resistance is a large value. So that large resistance is shunt with a capacitor, as shown in this diagram. And this is the capacitor C1, and this is capacitor C2, and this is inductor, and this is resistor. So now here this resistor is connected to the parallel combination. This rectangular strip is arranged in parallel combination. Resistor and capacitor are in parallel combination. And boundaries, this is lumped port RLC1, current flowing this direction, and this is capacitor C2, current flowing in the direction. So we need to define the current flowing direction.
Yes, ma'am.
So in case of off state, so this inductor is a combination of this resistor. This is a resistor. So this resistor is a combination of parallel combination of resistor and capacitor. So now double click on this one. So now selecting the resistance and capacitor values are in same time. Select the parallel, and the resistance is very large in off state, and this resistance value is here I am considering 15 kilo ohm, and capacitance value is 32 picofarad. Click the OK button, and this is the capacitor C1. So for off state the capacitance value is 32 picofarad, and this is the capacitor C2. For off state the capacitor C2 value is 32 picofarad, and this is the inductor. For off state the inductor value is 0.4 nano henry, and this is a resistor. Now we are considering the at the same time we are assigning the resistance and capacitance value are in parallel. So now here this combination of these four strips representing RF switch is in off state. Now select the radiation box, check the validity and analyze all. Go to the simulation, select validation button. The design is successfully validated. Now start the simulation, click analyze all button. So this is the S parameter curve when the diode is in off state. So and S11 value when the diode is in off state, the return loss value is minus 27.79 decibel, and S22 the return loss value is at 2.4 GHz operating frequency minus 28.3 decibel. So now here M1, M2 are the when the diode is in off state S parameter curve. So this is the diode is in off state S parameter curve. These two are the diode is in off state S parameter curve, and M3 and M4 are the diode is in on state. So this is diode in on state return loss value. And similarly VSWR curve. So when the diode is in off state, so this is the VSWR plot. Set to 2.4 GHz operating frequency. The VSWR value is 1.08, and this is the two-dimensional radiation pattern, gain radiation pattern, and two-dimensional directivity radiation pattern, and this is the 3D polar plot directivity. So the directivity value is 4.1 when the diode is in off state. So this is the procedure of we can design modeling of pin diode for off switching in reconfigurable antenna. So in this way, so we can use pin diode in any microstrip patch antenna. So we can achieve the frequency reconfigurable.